Good morning, ladies and gentlemen. Today we're going to introduce a new notation. Same concept, new notation. The name of this new notation is indefinite integration. When we say indefinite integration, all we're meaning is to find the antiderivative. Finding the antiderivative. That's what indefinite integration says. We have this notation that is similar to previous notation that we're used to. If you recall the definite integral, we would have limits on the integration symbol. Now we are introducing the integration symbol with no limits. But this is still the integration symbol. Integration symbol. We still have the integrand, which we're going to call f of x, is called the integrand. And dx is the variable of integration. And all this notation simply asks us to do, it says, hey, find the antiderivative of f of x. How do we read this? This is the indefinite integral of f of x dx. All it does is say simply find the antiderivative of f of x. And we know the notation for the antiderivative is capital F of x. If we're anti-differentiating little f of x, that's going to be capital F of x plus your constant of integration, where the derivative of capital F of x is little f of x. This part we knew, and all we're adding today is this new notation for indefinite integration. Let's go to some simple examples so that we can do 4 or 5 problems tonight. The most important rule to find antiderivatives or indefinite integrals is this. If you want to call it reverse of the product rule, you can. But if I'm going to anti-differentiate x to the n, where n is a real number with respect to x, if I'm going to anti-differentiate x to the n dx, all I simply do is add 1 to the exponent and divide by that numerical value. So I'm going to take 1 and add it to n and divide by n plus 1. Don't forget the constant of integration. This is the most important rule. This is the rule that we cannot forget. So let's look at some examples that use this rule. If I want to find the antiderivative of x to the 1/3 power, all I simply do, that's going to equal, keep in mind the integration symbol is gone. The integration symbol means, hey, find the antiderivative. I'm finding the antiderivative. So this is going to be x to the 1/3 plus 1 over 1/3 plus 1. Don't forget your constant of integration over here. What does that equal? Well, 1/3 plus 1 is 4/3. And so I'm going to have x to the 4/3 divide by 4/3 plus c. If I'm going to divide by a fraction, that's the same as multiplying by the reciprocal. We do not want to leave your answer in this form at all. We want to write your answer in this form. So the indefinite integral of x to the 1/3 is equal to 3/4 x to the 4/3. Let's do another simple example. If I want the indefinite integral or the antiderivative square root of x, the first thing I have to do is I have to write this square root function as a power, as a rational power. So the square root of x we know is x to the same as x to the 1/2. So what I want to do is find the indefinite integral of x to the 1/2. I do this integration. Add 1 to the 1/2. This is going to be x to the 1/2 plus 1 over 1/2 plus 1. Don't forget your constant of integration. 1/2 plus 1 is 3/2. Divide by 3/2. Divide by a fraction means to multiply by the reciprocal. So therefore, the indefinite integral of x to the 1/2 is 2/3 x to the 3/2. plus c. Eventually, if you want to go from this step to this step, you certainly can. Might be a good idea to write this intermediate step at the beginning. Let's do another example, a little bit longer one. Example number 3. I want to find the antiderivative of x cubed plus 1 over x squared plus sine of x dx. Before I deal with this piece here, I'm going to write him as x to some power. And we know 1 over x squared is x to the negative 1/2 power. Now I'm going to employ that antiderivative rule, where I add 1 to the exponent and divide. Therefore, and I'm going to integrate each term here. So the antiderivative x cubed is going to be x to the 4th over 4. 3 plus 1 is 4, divided by 3 plus 1. Negative 2 plus 1 is negative 1, divided by negative 1. And I know I want the antiderivative of sine of x. What do I differentiate to get sine of x? I have to differentiate negative cosine of x. The derivative of cosine is negative sine. If I want to end up with a positive sign, I have to anti-differentiate negative cosine. To clean this rascal up a bit, I notice this negative right here is going to make this term divide by negative, makes the whole term negative. And I have x to the negative 1/2, x to the negative 1. That's going to force that x to be downstairs. So the antiderivative in this case is x to the 4th over 4 minus 1 over x minus cosine of x plus my constant of integration. I think I have one more example for this short video. Here I want the indefinite integral of x times the quantity 5 plus 7x cubed. There is not a product rule for antidifferentiation. So what I have to do first and foremost is I'm going to multiply this through. Use the distributive property. Notice my integrand becomes 5x plus 7x to the 4th. X times 7x cubed is 7x to the 4th. Now I employ my very important property. Add 1 to the exponent. I have x to the 1. 1 plus 1 is 2. Divide by 2. 4 plus 1 is 5. Divide by 5. And this is the antiderivative. Here are some very simple examples that should certainly provide you with the tools to do the few problems that will be assigned today during e-learning. Thank you very much.